Okay, so very quickly, guys, I would like to solve this question using the ways I mentioned in my first video. Here you have a question. I'll read it out. The result of 5 times a number is same as 40 times a number raised to the power of minus half. Find the number. So the first thing you are going to do is to study your question. Read it inside your mind. Okay, 5 times a number, all this. This should be done within approximately probably 10 seconds. Right in your mind, depending on the time or duration you're giving to solve those problems. So this I have examined in my mind already. I've read it out to you and it's already on my mind. The next thing I'm going to do is to check what kind of problem it is. Obviously this is a word problem, and this word problem needs to be expressed mathematically before I solve. As this problem is, it does not require any diagram. Obviously there's nothing like maybe the diagram of something or something I'm supposed to draw. This is just to be expressed mathematically, which I am going to do now. Now, before I go further, there is a number that is unknown. So the first thing I'm going to do, I will say, let the number be, let's say, letter n. I have represented the unknown number with letter n, which we are looking for. And so, no diagram involved. And obviously, the parameters will be given when I write the mathematical interpretation. And so, the result of 5 times a number. 5 times a number means, since the number is n, 5 times the number. They said it's same. The result is same as 40 times the number raised to the power of minus half. The result is the same as 40 times the number raised to power of half. So this is how it is going to look like. So this is the mathematical representation of the word problem. From here, I can now solve the problems. And so, looking at it, this is an indices question. Indices. And immediately, indices, what comes to my mind is, okay, this indicial is an indices question and an indicial equation. And so what comes to my mind is, recalling all the laws of indices, and with that knowledge, I can approach this question. It will be easy for me to do that. By the time I'm solving, I would be recalling those theories or the laws of indices, and I'll be grafting them in here to solve the problem accurately. And so remember, our objective is to find n. Now n appears in 2 places here. We should be thinking of how we can make the n to become 1. And so what I'm going to do to solve this, 5 times n is 5n, which equals to 40 times n raised to the power of minus half equals to 40 n raised to the power of minus half. The next thing I'm going to do here is to divide both sides by 5. By dividing both sides by 5, I have 5n over 5 equals to 40 n raised to the power half over 5. 5 equals 5. 5 here, 1 here, 8. I'm going to be left with n equals to 8 n raised to the power half. So the next thing I want to do here is to bring the ends together. I want the ends to be together to be 1. There is no way this question can be solved without making the n to be 1. Remember that since it is an equation, eventually my answer is supposed to be n equals to something. And so I cannot be having 2n. 2n to be equating each other. It won't work that way. And the best thing I can do here is to divide both sides by n raised to the power half. Minus half rather. So we have n all over n raised to the power half equals to 8n raised to power half all over n raised to power half. And so this will cut this. Eventually we'll be having n divided by n raised to power half equals to 8. Remember that the power of n here is 1. And so also I can recall in law of indices, when two similar numbers or unknowns, when they divide each other, feel free to subtract their powers. In this case, I have n divided by n raised to power half. It will become n raised to power 1. The division turns to subtraction. Remember, there is minus half here. Because I don't want the minus and minus to come together, I will make it in brackets minus half equals to 8. Please permit me to continue here. So therefore, I have n minus times minus. We know bracket is multiplication. So minus times minus there is plus 1 all over 2 equals to 8. This way. And so here, I need to make these two a single fraction. Our LCM is 2. 2 divided by 1 is 2. 2 times 1 is 2. Plus 2 divided by 2 is 1. 1 times 1 is 1, which equals to 8. And so therefore, I get 3 over 2 equals to 8. Alright, actually there are so many ways to do this. I'll be using the two methods to solve that part. You have n raised to power 3 over 2 equals to 8. I can multiply both powers by the reciprocal of the power here. The reciprocal of this power, reciprocal of 3 over 2 equals to 2 over 3. So what I want to do is to multiply both powers by 2 over 3. Now, why I'm doing that is to make n to be alone, so that I'll be having n raised to power 1 eventually, like this. I have n raised to power 3 over 2, then times 2 over 3 equals to 8 raised to power 2 over 3. Now, they will cut out. My n will be equals to n raised to power 2 over 3. Now, 8 in index form is 2 raised to power 3. So I have 2 raised to power 3 times 2 over 3. Eventually, it will cut out. N equals to 2 raised to power 2, which is 4. Alternatively, when I get to this area here, I have n raised to power 3 over 2 equals to 8. And so, I want to use an alternative method to get my n. Remember that when you're having a power and it's a fraction, the denominator becomes a root. So here you are having roots. It will become a square root. And the square root of n, and then q. So this is n raised to power 3, and the 2 there becomes square root. Sorry, I don't know if you can see it properly. This is what I'm trying to do. NQ, and then this is square equals to 8. It's the same thing. So what I'm going to be doing is I'm going to square both sides. By squaring both sides, I have square root of NQ square equals to 8 square. And so therefore the square root and the square cut out. I'm left with n cube equals to 64 because h raised to power 2 is 64. And the next I'm going to do here is to cube root both sides. I have cube root of n equals to the cube root of 64. So the cube and the cube root cut out, and so therefore the cube root of 64 is 4. It's just an alternative method. So eventually we are getting n equal to 4. Thank you very much. Okay, so as I was saying, so here I have the square root of n cube equals to 8. Okay, so I think the best is I should do it this aspect again. My camera was not well placed initially. So the alternative method from here, we have n raised to power 3 over 2 equals to 8. And so therefore, we all know that in indices, when you're having the power of a number or maybe an unknown to be a fraction, the denominator becomes a root. In this case, what we are having here is n cube, the square root of n cube is the same thing as 3 raised to power 3 over 2. So 2 here becomes square root, then n cube equals to 8. So what I will do to get rid of the square root, is to square both sides. Square both sides. And so by squaring both sides, I have so here the square root and the square cut out. I'm left with n cube equals to h raised to power 2 is 64. And so again I have n cube equals to 64. How do I get my n? This is a cube. To get rid of the cube, you cube root both sides. Again, you cube root both sides. And so we have the cube root of n cube equals to cube root of 64. So the cube and the cube roots cut out. I have n equals to 4. Okay, so n is 4 here and n is also 4 here. And so therefore, this brings me to the end of the class of today. I really hope you enjoyed. Thank you so much.